Hello everyone. In this video we're going to be solving a system of equations. We have a polynomial system, x squared plus y squared equals 25, xz plus yz equals 35, and z squared plus 2xy equals 49. So I'm going to be manipulating these equations so that we can get something nice from here. So for that purpose, I'm going to double the second equation. That's going to give me 2xz plus 2yz equals 70. I'm going to keep the first one and the third one. Now my goal is to get the xy, xz, and yz with the same coefficient of 2, and then I'm going to add these three equations. When I add these equations, I get x squared plus y squared plus z squared plus 2xy plus 2xz plus 2yz. And the sum is going to equal 144 if you add those numbers. Now the left hand side of this equation is something well known, or you should know that. It is x plus y plus z quantity squared. It is a perfect square. And 144 is also a perfect square, so everything is perfect. Great. So from here we get two solutions. There are two numbers whose square is 144. The first one is going to be 12. So if x plus y plus z is equal to 12, we get the following. The second equation, remember, is xz plus yz. So what I can do is I can take out the z from that equation and write it as z times the quantity x plus y, and that is equal to 35. Now, putting these two together would be interesting. And what I'd like to do is, from the first equation, I can basically isolate x plus y and write it as 12 minus z. And this gives me something nice. Z times 12 minus z equals 35. Okay? All right, cool. Now, we are going to solve this equation for z. Let's go ahead and turn it into a quadratic equation. Put everything on the same side. Z squared minus 12z plus 35 is equal to 0. And this can be factored as z minus 5, z minus 7. So from here we get z equals 5 and z equals 7. So in other words, I just factored this using the constant term 35. So I'm looking for two numbers whose product is 35 and whose sum is negative 12. And those numbers are negative 5 and negative 7. And that gives me the following factors. Okay, so I got the z values from here. Z equals 5. If z is equal to 5, let me go ahead and rewrite them. If z is equal to 5, remember x plus y is equal to 12 minus z. So by subtracting these numbers from 12, you're going to get the values of x plus y. So x plus y is going to be 7 if z is equal to 5. And if x plus y is equal to 7, the next thing I'm going to do is use the first equation. Remember, the first equation gave me x squared plus y squared equals 25. And I can write this as x plus y quantity squared minus 2xy is equal to 25. Since I know that x plus y is equal to 7, this gives me 49 minus 25 equals 2xy. So from here we get xy is equal to 12. So we got now two equations for x and y. We're looking for two numbers whose sum is 7 and whose product is 12. And those numbers are 3 and 4. So we can safely say that our order triples are going to be from here, or maybe I can just write it as x equals 3, y equals 4, and obviously here z equals 5. That's one way to write it. At the end, I'm going to write them all as order triples. And then let's go ahead and proceed with the result, z equals 7, and see what happens from there. In this case, x plus y is going to be 5. And again, I can just write the x squared plus y squared as this, which is equal to 25. But here, x plus y squared is 25. Therefore, this gives us xy equals 0. And xy equals 0 means either x is equal to 0 or y is equal to 0. But their sum is equal to 5. So if x is equal to 0, then we're going to get y is equal to 5. And of course, z is equal to 7 in this case. Or x could be 5. Y could be 0, and z is still 7. And of course, we shouldn't forget to write the other solution here. X equals 4, y equals 3, because x and y are basically interchangeable, but z is fixed in this case. So we got those two sets of solutions. And then now we have to look at the other scenario, the case which is where x plus y plus z is equal to negative 12. Let's go ahead and explore that down here and see what happens. So if x plus y plus z is equal to negative 12, from here we get from the second equation, remember we were able to write z times the quantity x plus y equals 35. Because remember we had something like xz plus yz is equal to 35, and that's basically factorable. Okay, so now we have this and pretty much the same situation. The only difference is you're going to replace x plus y this time with negative 12 minus z. Therefore, you're going to be getting a different quadratic this time. Let's go ahead and solve it. We get negative 12z plus, actually that's supposed to be a minus sign, negative 12z minus z squared is equal to 35. And if you put everything on the same side, you get z squared plus 12z plus 35 is equal to 0. And as you know, this can be factored as z plus 5 times z plus 7 is equal to 0. And from here we get z equals negative 5 and z equals negative 7. Now we know that x plus y is equal to negative 12 minus z. So if you replace z with negative 5, for example, you get x plus y is equal to negative 7 from here. In this case, x plus y becomes negative 7. And in this case, x plus y becomes negative 5. This gives us x plus y quantity squared minus 2xy is equal to 25. Remember, this was our first equation. If x plus y is equal to negative 7, you're going to square it 49, and you're going to get the same scenario. xy is going to be 12. So now I have x plus y is equal to negative 7 and xy is equal to 12. So we're looking for two numbers whose product is 12 and whose sum is negative 7. Those numbers can be written as either negative 3 or negative 4. So x can be negative 3, y can be negative 4, or vice versa. And this is going to give us the solution. But in this case, z is always negative 5. Remember that. So we can basically write them like this. And from this scenario, we get x plus y quantity squared minus 2xy is equal to 25. X plus y is equal to negative 5, which is squared. That becomes 25. So xy becomes 0. And this means that either x or y is 0. But not both, because their sum is not 0. Okay, so from here we get the following. If x is 0, then y is equal to negative 5, because remember their sum is negative 5, and z is always negative 7 in this case. So we can write it like this, or we can write x equals negative 5, y equals 0, and z is still negative 7. And pretty much these are all the cases that we can look at. Are there complex solutions? That's something that hopefully you're going to be looking at. Now, I'm going to go ahead and summarize all these solutions and put it all together. So our solution set is going to look like the following. We have 3, 4, 5 as a solution, and we have 4, 3, 5 as a solution. Of course, you can put a comma there. We have the 0, 5, 7, as well as 5, 0, 7. And then we have the negative 3, negative 4, negative 5. We have the negative 4, negative 3, negative 5. And then we have 0, negative 5, negative 7. And finally, negative 5, 0, and negative 7. And this basically makes up all the solutions. Let me go ahead and move this stuff a little bit this way, so it's not cut off like this. Here we go. And this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.